Assalamu alaikum, dear cadets. I am Sheikh Wajid Ali and I welcome you all in today's mathematics class. As you all know that due to corona pandemic, the whole country has locked down itself. And so it is. We are taking online class. Boys, our today's topic is what? The last class. Okay. Before starting my class, again I am reminding you all that the world is going through or passing critical situation which is created by COVID-19 virus. Boys, you all know that since March 2020, we are in lockdown. Actually, the whole world is in lockdown, especially the educational institutions. So, boys, for this, because we want to save our students, save our children from this virus. So, for preventing COVID-19, you have to follow these steps. Here is some steps. You follow these steps. Okay, now we start our today's class. Okay, boys, you see, you already known what are the picture says. This like pedal force and unlike pedal force. So our last class or our today's topic is statics resultant of parallel forces. Actually, the last class of mine in statics. Okay, learning outcome. After the lesson, you will be able to find the resultant of parallel forces and especially solve statics problems of parallel forces. So, boys, in previous class, we discussed about formula, parallel forces, like parallel forces, unlike parallel forces, and solve some problems. So already we know the formula and the basic conception. In this class, I solve some problems that will be very beneficiary for all for solving critical problems. So here I solve some problems of like parallel forces and unlike parallel forces. Okay, problem one. Two parallel forces 20 Newton and 8 Newton acting at 2 points to 2.1 meter apart. Find their resultant and its point of application when they are like and unlike. So if the forces are like, then this is 1, and unlike, then it is part 2. So for part 1, here is two forces, 20 Newton and 8 Newton, right? And here the distance between A and B is 2.1 meter. And we have to find out the resultant. What is resultant? And we say the resultant goes through C. Okay, point C. And here it is the action application, point of application, or resultant passing point, or resulting acting point. Let two like parallel forces, 20 Newton and 8 Newton, and B respectively, their resultant is, we know that for like parallel forces, the resultant is the sum of their forces. So resultant is 20 plus 8, that is 28 Newton, which acts, we can say, at point C. So for like parallel forces, we know that, or unlike parallel forces, this is equal 20 into AC, 20 into AC equal to 8 into BC. So BC by AC equal to 20 by 8. And now we take 1. That is component, only component, that is BC plus AC divided by AC equal to 20 plus 8 divided by 8. For boys, write note down here. For like parallel forces, always we do only component. I again repeat, boys, write note down this point. Always we find out like the formula BC divided by AC. Okay, like one force divided by another, one distance divided by another distance. And then always we take component. Okay, so that is BC plus AC componendo and divided by AC equal to 20 plus A divided by 8. So we know that AC plus BC equal to AB, that is the whole part. So AB by AC equal to 28 by 8. We know that AB equal to 2.1 meter. So 2.1 equal to 28 by 8. So here AC equal to 8 into 2.1 divided by 28, that is 0.6. So resultant is 28 Newton, which acts at 0.6 meter internally from the greater force. Okay, greater force. Here it is AC is from the distance greater force. So the magnitude of the resultant is 28 Newton, which acts 0.6 meter inside from the greater force. So boys, I hope all of you understood this problem, and I will go now part 2. Two like parallel forces 20 Newton and 8 Newton act at A and B respectively. Their resultant is, we know that the resultant of unlike parallel forces is the difference between the forces, that is 20 minus 8 equal to 12 Newton, which acts at a point C. Because we know that the resultant of unlike forces acting the extended of the line of line between the forces, and which is the extended in the greater forces side, that is here it is 20 Newton side. So we can write 20 into AC equal to 8 into BC. And boys, here always we take this ratio as the greater distance divided by smaller distance, that is BC divided by AC equal to 20 by 8. Now we take the component. Boys, write down the note, that is for like forces we take component, and for unlike forces we take always dividend. So here BC minus AC divided by AC equal to 20 minus 8 divided by 8 equal to AB by AC equal to 12 by 8. So AC equal to 8 into 12, 8 divided by 12 into AB. We know that AB is the distance between the forces, that is 2.1 meters. So 8 by 12 into 2.1, that is 1.4. So the resultant is 12 Newton, which acts at 1.4 meter outside the greater force. So boys, again, one note is for like forces, our resultant will always inside the forces, and the what the resultant of unlike forces is always the outside of the forces, outside of the forces. So boys, now next problem. Okay, problem. P and Q are two like parallel forces. If P is moved parallel to itself through a distance x, which show that the resultant of P and Q will move through distance px by P plus Q. So here P and Q are two like parallel forces acting at A and B. Their resultant, first we find out the resultant at point C. Okay, so we can write P into AC equal to Q into BC. So we can write BC by P equal to AC by Q equal to AC plus BC. I said that for like parallel forces, we always take component. So AC plus BC is AB divided by P plus Q. So actually here is 3 ratio are always equal. So again, BC equal to P by P plus Q into AB. And for now, P is changed through A to D. Then their action of the resultant will move from the from a distance C to E. So now we can write P into D. Here P is the action point of P forces is D. So P into DE, DE point is resultant point. So P into DE equal to Q into B. Now again we write that DE by Q equal to B by P. So again taking component that is BE plus DE by P plus Q equal to BD by PQ. So we can write this way, or here we write as the ratio formula. Okay, so B equal to P by P plus Q into BD. So boys, here we can see that we find out BC equal to P by P plus Q into AB, and B equal to P by P plus Q into BD. Now resultant moves which distance? C. So we can write CE equal to BC minus B. We know that BC equal to P by P plus Q into AB here, and B equal to P by P plus Q into BD. So BC minus B equal to P by P plus Q, AB minus BD. Or we can say that AB minus AB minus AD, AB minus BD is the distance which we can say AD is X, as the distance moved, the forces P. So our resultant is our action of the resultant will move a distance Px divided by P plus Q. That is, we have to shown. Okay. Now, another problem. The resultant of two like parallel forces P and Q passes through a point O. Here, two like parallel forces P and Q, and when P is increased by R and Q is increased by S, the resultant still passes through O, and also when Q are replaced. Okay, here is a lot of transformation. So when Q are replaced by PQ respectively, show that prove that S equal to R minus Q minus R whole square by P minus Q. So boys, first let like two parallel forces P and Q. For P and Q, our action of the resultant is acting along at point O. So we can write P into AO equal to Q into BO. And again, for two like parallel forces, when we add R with P and S with Q, then the resultant also passes through the point Q, O. Then we can also write that P plus R into AO equal to Q plus R S into BO. Again, then up we can write P into AO plus R into AO equal to Q into BO plus S into BO. Here P into AO equal to Q into BO. We can eliminate these two from both sides. So you can write R into AO equal to S into BO. Okay. Again, the last transformation, two like parallel forces Q and R act at A and B respectively. Their resultant Q plus R, which acts along O. So we can write Q into AO equal to R into BO. So now we divide 1 divide by 3, then we can write P by Q equal to Q by R equal to P minus Q by Q minus R. And 2 divided by 1 is Q by R equal to R by S equal to Q minus R by R minus S. From these two we get, and we taking the what ratio formula. Okay, so here from equation 5 and 4 and 5 we can say that Q by R is same here. So you can write these two is equal. That is P minus Q by Q minus R equal to Q minus R by R minus S. So here Q minus R is double. So we can write R minus S equal to Q minus R whole square divided by P minus Q. Or S is here. Then we can write R equal to S plus Q minus R whole square by P minus Q. Or we can transfer this part here, then we can write S equal to R minus Q minus R whole square by P minus Q. So boys, you have to understood, you have to watch carefully this video. Okay, so this is are important, very important and interesting. So there is a lot of transformation in this problem, so you have to uh, learn watch this with pots. Okay, so now I going to next problem. Three like parallel forces PQR acts at the vertices of a triangle ABC. Their resultant, if their resultant passes through the in center, whatever be the common directions of the forces, prove that P is to Q is to R equal to sine A is to sine B is to sine C, and P is to Q is to R equal to A is to B is to C. So boys, now here a triangle is ABC and acting A point, acting forces P, and B point Q and C point R. And here O is, we say O is the in center. So acting along the O is P plus Q plus R. So for first forces Q and R, this is parallel forces. So our resultant will go passes through the point D. Okay, so here the in D point the resultant of two forces Q and R is Q plus R. So E and here for this line AD, the resultant of P and Q plus R, then acting along the O. Okay, so now boys, for these two forces we can write BD into Q into BD equal to R into CD. So here BD divided by CD equal to R by Q. That is equation 1. So boys, first we have to identify, we have to uh, mm, understood the clear conception. We have to understood the incenter. Okay, what is incenter? Incenter of a triangle is the what? The here is a inside a triangle, and we can say that the common is it is the angle, half angle, or the bisector of three here. For bisector of angle A, bisector of angle B, and bisector of angle C meets a point. Yes, that point is called the incenter. So here we have a clue, that is here OA line is, or AO line is the bisector of A. Okay, so AD line is the bisector of A. Okay, there is a tricks. So for triangle ABD triangle, we can write that BD by BAD. BD is the distance, BD by BAD, the opposite side, and AD divided by the ABD. So we know that BD here, it is the half angle. So angle B is sine BAD is the sine half of A, and AD here ABD is the angle, it is angle B. And from triangle ACD, again we can write that CD by half angle A. Okay, this is half A, and AD divided by sine C. And divide 2 and 2, 2 divided by 3, we can write BD by CD equal to sine C divided by sine B. That is, it is cancel and AD is cancel. So from equation 1 and 5, we can write, so BD by CD equal to R by Q. So you can write R by Q equal to sine C by sine B, or here you can write that Q by sine B equal to R by sine C. Similarly, from the forces P and R, that is here, we can write also similarly P by sine A equal to R by sine C. So after combining this, we can write P by sine A equal to Q by sine B equal to R by sine C. Okay, so that is our P is to Q is to R equal to sine A is to sine B is to sine C. So we proved the first part, and the second part we have to prove. So that is A by sine. We know that A by sine A, the triangle rule side. Okay. So A by sine A equal to B by sine B equal to C by sine C equal to 1 by K. It is, so we can write sine A equal to AK equal sine B equal to BK, sine C equal to CK. So here we put the value sine A equal to AK, sine B equal to BK, and sine C equal to CK. So all K we eliminate, then the ratio is P by A equal to Q by B equal to R by C. That is P is to Q is to R equal to A is to B is to C. Boys, this triangle type problem are really interesting. So you have to identify, and all you have to know the basic center, orthocenter, incenter, centroid, circumcenter. You have to understood this center of triangle are clear. You have to clear knowledge about that, what are this says, and what formula we can know about from this center. Okay, boys, I think this is the last problem. So this you have to watch carefully and learn this. Okay, if two like parallel forces P and Q, two like parallel forces. Okay, this is last problem. So you Learn carefully. Last is important. So, if two unlike parallel forces, P and Q. Here, for unlike parallel forces, you have to mention one forces is greater from another forces. Here, P is greater from Q. So, be increased by same amount. Here, same amount is we can take R. Show that the line of action of the resultant will move farther from P. Farther from it move further from P. So boys, this is really interesting and important problem. Okay, it can give your can anyone can give your exam in a lot of way. So you have to understand this. This will be for unlike parallel forces. Let two unlike parallel forces, I repeat, P and Q, and P greater than Q. So here, the resultant of the two forces P and Q in action or application on C. And if we add two for the same force R at A and B, that is P plus R here B, Q plus R, then the forces of these two forces, the resultant acting along D. Okay, we have to find out is greater. Okay, AC or AB. So first we know that from first figure we know that P into AC equal to Q into BC. Again I repeat that we take only component, or when we take ratio formula then we take only difference, only the minus. Okay, so AC minus BC, AC minus, so BC minus AC equal to P minus Q, that is BC minus AC equal to AB my P minus Q. So AC equal to Q by P minus Q into AB. And for boys, here for this I again use that the next is P plus R, force acting at A, and Q plus R, force acting at B. Then their resultant acting along the point D. So you can write here P plus R into AD equal to Q plus R into BD. So here we can write AD by Q plus R equal to BD by P plus R. Again taking minus, BD is greater, so BD minus AD equal to P plus R minus Q plus R. So R cancel, it is AB by AD. So AD equal to P Q plus R divided by P minus Q into AB. So taking 2 divided by 1, we get AD by AC equal to Q plus R divided by Q. So you can write that is 1 plus R by Q. So but it is greater than 1 because it is two forces and their ratio will be greater than 0. So it will be greater than 1, so it may be 1 point something or greater. Okay, so so we can write AD equal to something greater than 1 into AC, that is, so here AD is greater than AC, so the line of action of the resultant will move further from the force P. Okay, that's all lesson. All the I try to solve your important problem, and actually the different problem. If you understood my every class, then I think you have no problem in statics. So, boys, best of luck. And now I give you some homework. That is, three like parallel forces P, Q, and R act at the angular points of a triangle if their resultant passes through the centroid of the triangle. Whatever be the common direction of the forces, show that P is to P equal to Q is to Q equal to R. And number two, three like parallel forces PQR act at the vertices of a triangle ABC If their resultant passes through the circumcenter, whatever be the common direction of the forces, prove that P is to Q is to R equal to sine 2A is to sine 2B is to sine 2C, and last one is P is to Q is to R equal to A cos A is to B cos B is to C cos C. Okay, boys, before ending my class, I again reminding you that the corona second wave is starting and it is going to damage our country. So, boys, prevent yourself from COVID 19. And I again reminding you that don't go outside. Don't go outside from your house. Okay? Stay safe, stay fine, stay cautious. Allah Hafiz.